Hello everyone, this is Sai Sri and welcome to my channel. So in this video, let us answer to an important question, 4-mark question for second year. With a neat label diagram, explain the formation of image in a simple microscope, which is repeated in March 15, AP 16, TS 18 and TS 16. So first we have to define what is meant by simple microscope. So simple microscope is nothing but a convex lens of short focal length is used as simple microscope. So a convex lens having short focal length is called simple microscope. Now we have to take two cases. One is case 1, which we have to place the object in between F and O. So F is the principal focus, O is the pole of the concave lens or center of the concave lens. So in this case, the image is formed at the near point distance. So that is near point distance is represented as T. So let us see the diagram. You have to draw very carefully while drawing this diagram. So diagram carries you marks. So first of all, draw a convex lens, and this is the principal focus. This is center of curvature, and the object is placed between F and O. So this is the principal focus and this is the O. Here the object is placed, and you have to draw the image with the dotted lines because it is formed back side of the lens. And we have to take the two rays. This is one ray and this is one ray. They are extended back side. So when they are extended, you can see this image. So the image is formed at near point distance. So V is equal to D. The distance between the pole and the image formed is V is equal to D. D is nothing but near point distance. F is focal length. So the focal length is nothing but between O and F. F is focus. O is optical center. Here the image is erect, virtual. So erect means straight, virtual, magnified, and formed backside of the image. So the image is formed backside of the object, and you have to draw the arrows. These arrows are very important, so no need to draw here, just you have to extend the line. This is the lens. Use scale while drawing the rays. This is the image. We have to find the magnification value. So the magnification formula is M is equal to 1 plus D by F. So in case of the object is placed between focus and object, so it will be different if we place at focus. So the magnification formula is M is equal to 1 plus D by F. D is near point distance, F is focal length. And this is the diagram which we must draw without any mistakes. Now let us see the second case when the object is placed at focus. So at focus, if you place the object, how the image is formed, let us see. Case 2, when the object is placed at focus. So this is the lens. The object is placed at focus. We have to extend the lines backward. We are taking two rays. This is first ray and the second ray. Here we have our eye. Our eye is in relaxed stage. In this case, when we place the object at focus, and the distance, image distance will be infinity, because the image is formed at infinity. Just we have to extend the line. This is the convex lens. So in this case, the image is formed at infinity. So because of that reason, the image distance is equal to infinity. And the image is viewed with a relaxed eye. So in this case, we can see the image with a relaxed eye. Here the magnification value is M is equal to D by F. In before case, we got M is equal to 1 plus D by F. So in this case, the image is viewed with relaxed eye and the value is M is equal to D by F. D is near point distance, F is focal length. And the image, how the image is formed? Image is virtual and magnified. It is magnified and erect. and formed at infinity. These points you have to write must and should, and the diagram should be very neat and